All right, so looking at a few things out of chapter 2. First is the distribution of data shapes, distribution of data, and we're talking about the shapes. All right, so this bell-shaped curve right here is symmetric about the mean, and it's considered your normal distribution. All right, so what we mean by symmetric is that your mean will be in the middle, and then everything that happens on the left side of the mean also happens on the right side of the mean. Don't think they focus that much on it right now in this section, but as we progress forward, you will need to hold on to that idea because it will help us in the future. And that's why I put remember this one, because this is the one that's going to be used as we get into further chapters. So the bell-shaped curve is symmetric and it's considered our normal distribution. Notice the bulk of your data is in the middle, and then as you spread out, go to the right and left. In other words, get greater or smaller. You know, it's less of your data. All right. Everybody all right? Let's scroll up. The next one, uniform distribution, kind of looks like a block. And that just pretty much have the same level of distribution as you go from the right to the left. Yeah, probably should have left it like that. Yeah. All right. Yeah, I'm just playing with seeing how long that would look. But yeah, same level of distribution when you look at uniform distribution. Now, the next two is where a lot of people had a little bit of confusion on. So that's why I wanted to talk about it. When it says that your data is skewed left, if your data is skewed left, to me, that sounds like being pushed left or the bulk of your data is to the left, but that's not exactly what's happening. If it's skewed left, that means the tail of your data will be to the left. And that means the bulk of your data is actually to the right. So if you can remember, if it's skewed left, that means the tail is to the left. All right, the tail of your data is to the left. All right. And then the opposite happens for if it's skewed right, that means the tail of your data is to the right and the bulk of your data is over here to the left. So being skewed left and skewed right really is referencing the tail. Any questions on either one of our distributions? See if I can put all four up. It's kind of small like that. I don't know if you can read it, but it's all four of them. Bell-shaped curve, uniform distribution, skewed left and skewed right. All right. Scrolling up. Everybody good with it before I scroll all the way up? All right, so the next thing is the stem leaf plot. So your leaf or your leaves will be the rightmost digit of your data value. Your stem is going to be all values that precede the rightmost digit. So if you look at our two examples right there, if I have the number 53, my leaf is the 3 and the stem is 5. If I have 127, my leaf is the 7, and the 12, 1 and 2, will be considered my stem. All right. Everybody okay if I scroll up? Put this into work. All right, so here's our data set. We're going to do a stem leaf plot to this data set. 41, 50, 56, 71, 72, 72, 75, 80, 80, 82, 83, 84, 88, 88, 89, 91, 92, 93, 100, 101, 101, and 112. So they're all in order, but of course your data set does not have to be in order when they give it to you. I just happen to do it this way. So we got our minimum. See, I marked off the minimum and our maximum value. You'll see why in a second. We'll just give you guys a chance to write the stuff down before I go all the way in as far as creating this stem leaf plot. All right. So looking at our minimum and maximum, that lets me know that our data set, with the minimum being 41, maximum being 112, this data set goes from the 40s to the 110s. All right, and let me erase this so we can walk through it. All right, so you set up your stem leaf plot like this. Like I said, we're going from the 40s to the 110s. So that's why I have 4, 5, 6, 7, 8, 9, 10, and then 11. Because remember, if I have 112, this is my leaf, and this right here is my stem. So that's what we're talking about. That's where I got that 11 from. All right, so now looking at our data set. First number is 41. So under the 40s, I would put 1. And that's all I will put. So each leaf represents a data value that you see. So like I said, that would be 41. The next one would be 50. So I'll put a 0. Then 6 for 56. And that's it. So now notice we don't have a 60, a value in the 60s. So you don't put 0 because that will represent 60. You would just leave it blank. And then go to 70. You got 71, 72, 72. So even if there's a repeated value, you have to write it that many times because that represents that data set or that data value in the data set, excuse me. Then you got 5. Then for the 80s, you got 80, 80, 82, 83, 84, 88, 88, 89. 90s, you got 91, 92, 93. For the 100s, 100, 101, 101. And then for the 110s, you have 112. All right, so before we go any further with that, questions on what we did there, make sure we're okay. All right, so you may ask yourself, well, why would you do this versus anything else? So, statistics is all about creating these graphs, charts, or presentations when it comes, whether it be numbers or pictures or whatever, that will adhere to your audience. Maybe you're trying to sway your audience to your argument and to your side. I know you've heard this, the phrase "numbers never lie," but in statistics, you'll find out that they can mislead. So you can take numbers that somebody would use, let's say in a presidential candidacy, that under this president, this, that, and the third happened. Well, if somebody's really good with numbers, they can take those same numbers and flip them. They can say the total opposite. So you really would learn, once you deal with statistics a lot, that, a lot of numbers that they float out there really don't mean much. unless you present them the right way and done the right amount of research. But in this case, I would use this type of graph if my audience is an audience that like numbers, because really all this is, if you look at it, it's just a bar graph, you know. So if you have somebody that like, or an audience that like pictures, then you would do a bar graph that's more colorful, and have blue, maybe have red and all the stuff like that. But if you have a audience that's more numerically, inclined, or numbers impress them, then maybe you would do something like this to try to keep them interested in the things that you have to say. So it's really all about, adhering to your audience. And but you can take the same data and create another type of graph, pie graph or anything that will be more appealing to another type of audience. So that's what this was for. So like I said, brought this up because I know people had asked questions about it before. So just making sure everybody's clear on that. Questions on anything I've written before we go any further? Questions on anything? All right. So, yep, this is the stuff that we talked about last class. So let's make sure, just in case anybody's first day, you have chapter 1 and chapter 2 definitions in my math lab. They're on that left panel. So out of chapter 1 and chapter 2, we said that those will be due on the 22nd. All you got to do is do those. You want to type them up, or if you want to write them up in your notebook, scan them, take a picture or whatever, shoot them to me an email. I already have a few of them already. So good job to you guys, because y'all right on it. So some people have already turned them in. Those are just terms and definitions that we would go over. If I was doing a lecture, I'll be writing them, you'll be copying them, whatever. So to remove that boring part of the process, just go ahead and send them to you guys. They're in the book, in the e-text, everything's in order, so it wasn't made to be hard. It wasn't, created to be a scavenger hunt, and I should be an easy 100. So as soon as you get those to me, then I'll go ahead and put them in my math lab, give you your grade in 100, and you go on. So in my math lab, though, you also have homeworks 1-1 through 1-5. All of them don't have the same amount of problems. Some may have 10, some may have 8. I think one of them had 17. So depends on what's going on. Also, a lot of the definitions that you're going to see in those definitions will be in your homework assignment. So a lot of it is repeated. I see your hand. Let me mention this as well before I go there. And then homework, you have 2-1 through 2-3 out of chapter 2. So Cooper, no, you say your hand.
So when is the homework supposed to be due?
Now your homeworks have a hard due date, which is May 7th, that first week of May, which is the last due date that I could give you guys. So you want to knock it out as soon as possible, but you have the flexibility until May 7th. That's all I got. You know what I mean? So I gave you guys whatever I put in my math lab. We'll have this hard due date, which is May 7th. But as we progress throughout the course, that's your gauge. Once we get into chapter 3, you really want to be working on getting out of chapter 2 and being done with that stuff. And so as we progress throughout the course, that's how you want to look at where you should be in your homeworks.
When's the first test?
It's already posted.
Okay.
Yep, already posted. Chapter 1's test is already posted. And so as soon as you're ready to knock it out, go ahead and do it so you can move on and get it done and get out of there.
Does the test also have a hard due date, or?
Yep, everything in my math lab is 5/7.
Okay.
But like I said, you don't want to wait until May 3rd to get started. You know what I mean? So what I did was just I gave room for life to happen, and you don't have to ask me for an extension. You just know you got to get caught up. All right.
All right, sounds good.
All right, cool. I saw a couple other hands. Anybody else? Mr. Noel, was that you again? I see hand raised.
No, that's not me.
Okay.
Right. It's me. Sorry. I think you might have gone over this already, but the tests are due at our convenience with the hard date of May 7th, or.
Yes.
Okay. Mm-hmm. So is there any way that I can find, like, in the syllabus? I don't think it was in there. What is going to be on test 1 and test 2 and things like that? Because I don't know when.
Chapter 1 and chapter 2. Now, those definitions, that's all chapter 1 and chapter 2 is on.
Oh, okay.
Yeah. So now for the other tests, there will be a test review that's going to be, I think, matter of fact, hold on. Let me go into my math lab and I'll show you what I mean.
So test 1 is chapter 1, test 2 is chapter 2.
No, I'll show it to you in my math lab. It's laid out in my math lab. Yep. If this will come up, there we go. Give me 1 second.
Okay. And then last question, are the tests cumulative or is it just the final test or cumulative?
Now, each test is going to be on 2 chapters apiece. And then your final exam will be cumulative. I know last semester it ended up just being on the last things we were talking about, but we'll see as far as the final exam. But the regular tests that you have, let me go and share the screen, they're just on whatever you're talking about at that moment. So let's go in here and I'll show you. It should be reflected in my math lab when you see it. All right, so for those who weren't here the first day of class, this is where chapter 1 and chapter 2's definitions are, right here on this panel. All right, and where it go? Homework right here. And just showing everybody, haven't gotten to her question yet, but this is how your homework is laid out. For those who hadn't seen, see that 5-7, that's what Mr. Noel was talking about as far as your due dates. And you see right here, test review. So notice it says chapter 3-4. And next one, test review for 3. That's chapter 5-6. And that's supposed to be test, and that might be our final test, we'll see. But that's the 4th test right there. So now when you go to your actual test, the quiz and test. So your first 2 tests are posted. So you see right here, Ms. Lauren says chapters 1 and 2. And then right here, test 2 is 3 and 4. So is that what you were talking about? What's going to be on the test?
Yes.
Okay. Yeah.
And you said it's 4 tests total?
It's going to be 4 tests total. It's either going to be 4 tests and the final, or I might make that 4th test the final. It depends on how our time run. What's supposed to happen is it's supposed to be 4 tests and then a final. But if we run out of time, then that 4th test will probably be the final. And I'll just massage it in such a way that, that it'll work out for us. So, yeah. All right. Any more questions on that? Or any more questions on anything? And I did answer all of your questions, right, Ms. Lauren? Let me make sure.
Yes.
Okay, cool. All right, anybody else? All right, I see 2 participants' hands raised. I don't see who raised them though, so just unmute and let me know what you got. Nobody else? So is that, let me stop. Let's go to participants.
Hello?
Yeah, what was that, Lafrage? How do you say that?
Yep.
Okay.
Lafrage.
Gotcha. All right, cool. So what you got, sir?
Yeah, I was wondering if these Zoom meetings were a part of like mandatory attendance.
Man, you don't want to come to class?
No, I was just wondering.
No, yeah, I understand why you wanted to try not to come to my class. No, I'm just messing with you. No, well, the way, I don't know if you hear the first day of class, but if not, it's all good. The way I say that I will solidify your attendance is through my math lab work. So if you come to class, I would rather you come to class, but the way you can make up for not coming to class, because what's going to happen is because I record the lectures and I shoot it to you guys, then I understand that you could be making up the lecture on the back end without me even knowing it by going to YouTube and looking at the lectures. So the way you can make up for the attendance is by making sure that you're active in my math lab. So when I go look up and try to solidify that you're active, I can see my math lab, that you got a timestamp because you came in, you did such and such work, saved and went on out. And that's how you can do that.
Okay. And then for the definitions, I just screen cap once I'm done with them and then email it to you.
Yep. Yep.
Okay, cool.
Yep. All right. Anybody else? Anybody else? Is everybody good? Everybody straight? Before we go into this weekend, we know what we have to do. Go back to my notes. So we're looking at those definitions. We want to get those in as soon as possible. And then you want to knock out chapter 1 and chapter 2. I don't know, I erased it and put it back. Chapter 1 and chapter 2 in my math lab as soon as possible as well. And the test at some point, as soon as possible, because you remember next week we're going to go into chapter 3 and start our real lectures out of chapter 3. And remember, we only got 8 weeks. So it's one of those classes wherein we don't really have the luxury of relaxing, you know what I mean? So we have to get 16 week worth of content into 8 weeks. Now, I'm not gonna overwhelm you. I try to do my best to pace it out, but we do have to get some stuff. We do got to get moving, you know what I mean? So I kind of giving you this first week without any lectures, for real. And then we'll get into chapter 3 on Monday. All right. Anything else? Anybody else before we close out? Everybody good? Oh, also, anybody else, if this is your first day, the class will get started. I had a conflict. I thought the class started at 7. It actually starts at 6. And so I'm gonna meet in the middle, and we're gonna start at 6:30. That's not gonna do anything as far as us on the back end. I'm not adding a half an hour on the back end of anything. I don't need, I think the class ended at 8:45. I don't need 6 o'clock to 8:45 to go through the things that I want to go through. So with that being said, I'll get through the lecture. When I'm done with the lecture, if you have questions, you can always feel free to stay back. When I'm done with lecture, that doesn't mean I'm closing out class completely. I'm done, so that means you got to be done type stuff. No, what that means is that I'm done with lecture, and I will stay there. And if somebody have any questions, I'll answer questions until no one else have any questions. But that's still your time, and you can take advantage of the time. Or if you're done, then I'm done, and then we're going about our day, right? So just throwing that out there. If you have questions, you can always ask them after the lecture is over. Just because I say I'm done with lecture does not mean we have to close out. But if everybody's gone, I'm gonna just sit up here till 8:45, wait for somebody to come up or not. So once everybody say they're done, just like on a night like tonight, I'm done. I say, anybody have any questions? Nobody have any questions? Then that means we're done for the night. But just letting you know that option is there if you have questions that you want to ask. Also, if you want to set up an office hour, time to meet outside of class, that's available to you as well. Just shoot me an email, and then we'll discuss what hour time can fit both of our schedules, and we'll set it up, go from there. All right, so everybody good? Okay.
Are you gonna be posting these?
This video?
Mm-hmm.
Yes, I will. It's recorded now. So before the week is out, I'll shoot you guys a link. I'll create them in YouTube, shoot you the link, and then you'll be able to review it at your leisure.
Cool.
All right. Sounds good. Sounds good. Anybody else? Everybody good? All right. And if a question comes up, shoot me that email, and I'll respond accordingly. I might not be able to think of everything right now, but if something comes up, feel free to shoot me that email. All right. All right, guys, you know what you got to do. Chapters 1 and chapter 2. And we'll meet back on Monday. See if anybody have any questions. If not, then we'll roll on into chapter 3.
Have a good night, Mr. Tucker.
You have a good one as well. Y'all have a great weekend. Be safe.
Yeah.
Take care.
Oh, okay. So I had a question about the homework.
Mm-hmm.
2 questions. Okay. So I'm not able to access, because I didn't know I couldn't access Pearson, like the homework questions on my phone, and I don't have access to my laptop right now.
Okay.
But I had a question about number 7 and 8 and 12 and 13. They're both about the same topic, so I clumped them together.
Okay, but you don't know what they were?
Yeah, I don't remember my exact questions because I wasn't able to see what the question was.
All right. What homework assignment?
1.1.
Let me see if I can see what you're talking about. See, you one of the people that like to keep stuff to yourself, and then people could be benefiting for your question, And you'd be like,
No, it was, I
nah.
was gonna ask, but when you said, "Oh, hang back if you have questions," I just figured it was better for me to wait and then ask.
You just don't want nobody to benefit from your questions. I see you
Well,
selfish.
it's recorded, so if they watch the recordings, then they'll find out.
All right. So what numbers again? What was it again?
It was 7 and 8, and then
All
12
right.
and 13.
Shoot. All right. So let me see. Where's my? Oh, that's the
Are you
wrong
able to
button.
like screen share it?
Yeah, that's what I'm getting to now. All right. Was this it? Determine whether the underlined numerical value is a parameter or statistic.
Yeah.
On your reasoning.
Yeah.
All right, let me give you the page number that this is on before I give you the answer.
Yeah, I had the definitions right in front of me, and I was like, I don't understand why I'm not getting this. So.
It's all good. Where is my? Let me see if I can just pull it up right here then, since I can't find my book. All right, come on. Science of collection, nope. Get to the page, population, and so they asked us, is this a parameter or statistic? So statistic is a numerical summary of a sample. Parameter is numerical summary of a population. Okay, so that's going to be the difference. So when we talk about a sample is a piece of the population. Population is the whole thing. Sample is a piece of the population. So when you're talking about, let's say the student body at TCC would be the population, and this classroom would be a sample out of that population.
Okay.
So, and this is just, I think some other people are up here with us, so I'm just show them as well. So this is the spot in the book where they talk about it. Statistic is a numerical summary of a sample. Parameter is the numerical summary of the population. So that's what we're leaning on. That's off of page 5. So let's go back to it. So 2 students out of all 29 students in a class have red hair. So this, you're talking about 2 out of the 29. So that's a sample. So this should be a statistic. And so now we just got to figure out which statistic it is, as far as the explanation is concerned. So statistic because the data of the 2 students is a population. Note, statistic because the data of the 2 students is a sample. Data of 2 students. Yeah. Data set of all 29 students. No,
You
statistic
said,
because.
oh, sorry.
No, I was just reading them out and just seeing, because we know it's going to be a statistic because we're talking about 2 out of the 29.
Yeah, you said it was a numerical summary of a sample.
Right.
Is this?
Mm-hmm. So I'm just trying to see which one of these, because that means we have 1, 2, 3, 4 options here. So I'm just reading through the options and see which one best fits what we're talking about here. So it's a statistic because the data set of all 29 students is a sample. But the data set of the 2 students is a sample. See that, like playing with words. So it got to be this one right here. Yep, got that wrong. Statistic, numerical. Yeah, that's what I said. So the statistic because the data set of all 29 students is a population. That makes sense. Statistic because the data set of all 29 students. Statistic because the data set of all 29 students is a population. That doesn't make sense. Let me go back here to the population. So what is the data set of the 2 students is a population? That don't sound right either. Data set, parameter for the data set, no. Statistic, because the data set of the 2 students is a sample. 2 students of because it's the way they're saying it. So I'm trying to figure out which one's the right way according to the way they're saying it. 2 students out of all 29 students in a class have red hair. 2 students out of all 29 students in the class have red hair. And that shouldn't be right. So they said it was E, parameter, because the data set of the 29 students is a population. Parameter because the data set of all 29
So like, are we
students.
able to go back to, sorry, I'm unprepared, but are we able to go back to the parameter and statistic definitions so I can like read through it a little bit better?
Yeah. There you go right there. Parameter. So 2 students, determine whether underline is a parameter. 2 students. So the 2 out of all 29. Parameter because the data set of the 29 students is a population. Data set of the 29 students. So you said 8 is like that as well.
Yeah. Okay. I'm glad I'm not confused by myself.
No, because because they playing with these words, and so
Yeah.
they playing mind games with you. So the average age of a man who had walked on the moon was 39. The value of the parameter because the man had walked on the moon. And see, to me, that one. Okay, so that one made sense. Okay, hold up. So going back. So looking at this one, number 8, it said the average age of men who had walked on the moon was 39 years, 11 months, 15 days. And so that one made sense. The value is a parameter because the men who had walked on the moon are a population. So that one, I got right with no problem. But this one, 2 students out of all 29 students is in a class have red hair, and they say that is a parameter because the data set of all 29 students. That's weird because the 2 is what we're talking about. We're talking about 2 students, though. That should be a sample. All right. So you said 7, 8, and then what was the other one?
12 and 13.
12 and 13.
And I think I had a really specific question for those 2. I think I might have actually ended up understanding them, but I just have to see the question to remember.
All right, so that's 12. Determine whether it's quantitative variable, discrete, or continuous.
So if I remember correctly, I think discrete was countable and continuous was not.
Right. Mm-hmm.
So I think that's what it was. So it gave me a question that said, like the length of a rock song. And to me, when I sit here, length of a rock song, the length of any song, you measure it in minutes. So to me, it's countable. So I chose discrete, and it said it was wrong. It was continuous. So I was thinking, am I thinking of it in the wrong angle? Like, are they saying it broad? Like it could be any song. So it's has a numerous amount of options of what it can be, or
because they didn't say specifically what song. That could be the way that they're playing it because it's all about wording. You know what I mean? So if they said, the specifics of, I don't know, some, the actual name of a song, then that it's going to be 4 minutes and 17 seconds. Then there's no question on it. But if they just say a rock song, then that could vary. That could vary. So that's probably why they went continuous there.
So then using that information, then this one would be continuous because it's not countable. This specific question.
This one right here, the depth of a sunken pirate ship. Or are you talking about which one?
Yeah, that specific question.
Yeah, this one should be continuous. Because see, whenever you're dealing with measurement, it should be continuous. Yeah, so whenever you're dealing with measurement, it should be continuous because you also can have, let's say you're measuring like weighing a sub in a deli. Like if your scale is more accurate than mine, Mine may say 1.5 grams. You all can say 1.57 grams. Somebody else can say 1.58 grams. You know what I mean? So whenever you're measuring something, something could be measured. That's considered continuous. Good questions. Good questions. So I'm still stuck on that other one though. Go back. Oh, before I go back to looking at this one, trying to see if I can make heads and tails of it. Were you good on continuous and
Yes, I understand that one.
Okay. I'm just trying to figure out why they said this is a parameter versus being statistic. Right. Determined and undenied, blah, blah, blah. It's a sample. That didn't help. Okay, so that didn't help at all. Yeah, so this one is a parameter because the data set of all 29 students is a population. 2 students out of 29 students. Well, yeah, I guess you just mark that one, just chalk it up to the game, I guess. I don't know. I just don't understand why they would go parameter here because we're talking about the 2 students. 2 students out of all 29 students in the class have right here.
So is it a possibility that we might run into a question like this on the test, or did you make the test questions yourself?
Nah, I mean, if you did, the only way you run into something like this is if they change my test problems, because you have a pool of problems that you pick from. So if I choose, let's say 1.1.7, then there are like maybe 5 problems like that. If you see this one, I'll give it to you. It shouldn't be up there, but if you see this one, don't worry about it. Just tell me, I'll give it to you. Because to me, the wording, still not so sure if that is right. Because mistakes happen too as far as programming is concerned. I'm not willing to yield to this being right until somebody explains it to me. So, but it's all good. I'm not trying to say like I'm always right, but I'm just saying like it don't make sense according to the definition that I normally see. So yeah, if you saw this one on the test and you let me know, I'll give it to you. Ain't a big deal. So, all right, anything else? You good to go? All right, see the thumbs up. I see a few people still in here. Anybody else before we close? Make sure we good. All right.
I had a question.
Yes.
So I missed the first day, so I'm still trying to get familiar with the math lab thing. Where do I go? Is everything for the textbook and all the definitions on that e-texting and that page you just pulled up for the homework?
Yep.
Okay.
So hold on, let me go back. So you can go right here to either e-text or chapter contents.
Okay.
And that'll be your book, chapter 1.1. Or I don't know if you saw when I pulled it up earlier, when you were in the assignments, if you go to the help tools, they said go to the textbook. So you could have went to the textbook through your homework assignment as well. But it'll bring you right here. And this is the exact same text as, if you bought the hard copy.
Okay. And the homework that you just had pulled up was on there too?
Yep. So let me go back here. Hold on, I got a screen in my way. Oh, yeah, there you go. All right, so homework is right here. And all your homework assignments. And then quizzes and tests.
All right. So the assignment 1 and 2 and 3, we're not worrying about those yet, right?
Nope, and we may not because this is a shortened class. On my 16-week class, then we would take time for that. We may not have time for it, so I told the class I would let them know.
All right.
Also, since your first day, we talked about this. Don't do these down here, pre-test, post-test type stuff. Notice it says sample, tests, and quizzes. I just couldn't get those. I didn't mean to click that. I can't delete these. That's something my math lab has. So these are your tests right here.
Okay.
Yep.
Got it.
All right. All right. Sounds good.
Thank you.
Yep. No problem. Anybody else? Anybody else? Everybody good? All right. So you guys have a good one. Be safe. Have a great weekend. And like I said, if any other questions pop up, feel free to email me and we'll make this thing happen. All right. Y'all take care.